In the final winter of the Second World War, as British armor divisions pushed deeper into territories once considered untouchable, a discovery was made that stunned even the most experienced officers. It wasn't a secret weapon hidden in an underground bunker. It wasn't an experimental jet or a coded message. It was something far smaller, almost ordinary at first glance, a set of lenses and mechanical parts pulled from the turret of a battered German Panther tank. But the moment British engineers looked through those optics, they realized they weren't staring at simple glass. They were looking into the future, a level of precision and clarity no Allied tank had come close to achieving. Rumors had circulated for years among frontline crews. Stories whispered in mess halls about how German tank gunners seemed to spot targets at impossible distances, how Panthers and Tigers were able to open fire even before Allied tanks had identified what direction the attack was coming from. Many dismissed these stories as battlefield exaggeration. After all, in war, every defeat grows through myth, and every enemy ability becomes superhuman in memory. But on that cold day in early 1945, when the Panther's intact sighting system was recovered, the British command suddenly understood that the rumors were not myths at all. They were warnings the Allies had never fully listened to. The Panther tank itself had always been a point of fascination and frustration for Allied crews. It wasn't the heaviest German tank, nor the most iconic, but it was, in many ways, the most dangerous. Its long-barreled 75mm gun could tear through Allied armor at distances where British and American rounds simply bounced harmlessly off the front glacis. Its sloped armor, inspired by the Soviet T-34, made it resilient far beyond its weight class. Yet its true deadliness, invisible to the outside world, lay hidden one layer deeper. The German obsession with optics and mechanical precision gave the Panther something Allied engineers never prioritized: the ability to aim with extraordinary clarity. Long before the war, German industry had led the world in optical craftsmanship. Companies like Zeiss and Leitz had already achieved near-legendary status for their lenses, microscopes, and precision instruments. When the Wehrmacht began expanding its armored forces, it drew heavily on this industrial talent. By the time the Panther entered production, its rangefinders and sighting equipment weren't simple accessories. They were works of engineering art. That contrast was growing more obvious as the war neared its end. On the Allied side, tank optics were functional, basic, and standardized. They were built to survive rough handling and quick production schedules. British tank crews were trained to rely on teamwork, communication, and maneuver tactics to overcome the slower-aiming, methodical approach of German vehicles. But the Panther changed the equation. Its gunners didn't need to wait for the perfect moment. With a glance through the Termsiel Fernrohr, the TZF sight, a Panther gunner could judge distance, adjust aim, and deliver a shot so precisely that it felt less like tank warfare and more like long-range marksmanship. British crews fighting in Normandy and the Ardennes felt that precision long before they understood it. Many recalled seeing the flash of a German gun in the distance, followed by an immediate impact on their armor. Some remembered their own shots falling short or veering off, because their sights simply lacked clarity needed at those ranges. It wasn't about bravery or skill. It was about equipment. And the Panther had equipment the Allies never expected. The moment the recovered optics arrived at a British engineering depot, the mood changed instantly. Officers crowded around the wooden crate, like archaeologists, examining the relics of a lost civilization. One polished lens, one gear assembly, one finely machined reticle after another revealed a level of craftsmanship far beyond anything Allied factories were producing in mass quantities. Reports from that day describe officers picking up the sighting tube, holding it to the light, and going completely silent as the clarity snapped into focus. One engineer reportedly whispered, "No wonder they could hit us first." But the shock didn't end there. This advanced sighting system wasn't experimental. It wasn't reserved for an elite unit. It was standard. Every Panther that rolled onto battlefield, no matter how rushed its assembly or how desperate Germany's situation became, carried optics so refined that a trained gunner could pick out a target through smoke, fog, or fading daylight. Behind the front lines, British intelligence officers began reconstructing the story piece by piece. How had Germany maintained such optical superiority despite bombing campaigns and resource shortages? How had they managed to keep quality so consistent across thousands of tanks? The more they learned, the clearer the picture became. German industry had spent decades perfecting the science of seeing, and in armored warfare, seeing meant surviving. As the analysis continued, the British command realized this wasn't just a discovery, it was a revelation. The Panther's optics weren't just better, they represented an entirely different philosophy of warfare. A philosophy built on precision rather than numbers, craftsmanship rather than speed, and the idea that a single well-placed shot mattered more than a dozen rushed ones. And now, for the first time, the Allies understood exactly why the Panther had been so feared. When British analysts finally mounted the recovered Panther optics onto a test rig and aligned it with a distant target range, the room fell into a quiet disbelief. Technical officers expected an improvement, perhaps a cleaner image or a more precise reticle. Instead, what they saw looked impossibly sharp, as if the world beyond the lens had been scrubbed clean. Every ridge, every shadow, every edge of the steel target shimmered with a clarity that seemed out of place in 1940s battlefield technology. The Panther's main sight, the TZF-12A or 12B depending on the production model, was not just a window. It was the visual equivalent of a scalpel. Its magnification, focusing ability, and light-gathering power were so refined that British engineers joked that the German gunner didn't aim the cannon. The cannon aimed itself. When they compared it side by side with British tank sights, the difference felt almost unfair. The British number 39 and MK for sights work well enough under controlled conditions, but they were built for durability and rapid mass production. Their optics were serviceable, utilitarian, and kept to a level of quality that factories could produce in the tens of thousands. Looking through one after testing the Panther system felt like stepping backward in time. Reports recorded officers raising the British sight to their eye, then switching back to the German one, then repeating again, as if trying to prove to themselves that the contrast wasn't a trick of the light. The Panther optics weren't just clearer, they allowed for faster identification, more accurate range estimation, and easier tracking of moving targets. In tank warfare, that difference meant life or death. To understand why these optics were so advanced, British intelligence traced the entire manufacturing chain. They discovered that German factories, even in the chaotic late years of the war, maintained quality control levels that bordered on obsessive. Skilled craftsmen inspected each lens by hand. Precision grinding machines, many designed by Zeiss engineers, shaped the glass with tolerances that defied expectations for wartime production. A single flaw, a scratch, a bubble, a slight distortion, meant the lens was rejected. In Allied factories, such imperfections were often accepted, especially during peak demand. But in German optics plants, the standards remained uncompromised. It wasn't efficiency, it was ideology. To the German war machine, optics were sacred. This obsession seeped into every component of the Panther sighting system. Its reticle wasn't a simple crosshair, but a detailed ballistic pattern etched with remarkable precision. The gunner could use it to judge distance, movement, wind, and the slope of the terrain with shocking speed. If the target was 1,200 meters away, the sight told him. If it was moving left at a moderate pace, the sight guided his lead adjustment. The British realized that German gunners weren't making impossible shots out of luck. They were making calculated shots using technology that nobody else had. For frontline tank crews, this discovery explained years of battlefield frustration. British Sherman Firefly crews had long wondered how Panthers managed to open fire from the shadows of tree line, while Allied tanks strained to see through muddy glass or narrow vision blocks. Now they understood Panthers could see through environments their own machines struggled with. One British officer recorded in his report that looking to the Panther sight at dusk felt like cheating daylight. The lens gathered in concentrated fading light, keeping the battlefield visible long after Allied optics had surrendered to darkness. This advantage often meant that the Germans got the first shot in evening engagements, a critical edge when a single penetrating hit could knock a tank out of action. Even more astonishing was how well the optics held up under battlefield conditions. Despite the Panther's mechanical issues, poor fuel reliability, fragile final drives, and complex maintenance needs, its optics remained remarkably resilient. Tanks with severe turret damage still had functional sights. British engineers marveled at the craftsmanship that ensured nothing came loose, nothing fogged, and nothing misaligned even after hours of violent recoil shock. But the story of German optics extended beyond the battlefield. As British intelligence dug deeper, they discovered that the Wehrmacht had invested immense resources into optical superiority long before the war even began. German snipers used scopes superior to Allied counterparts. Artillery units relied on rangefinders that were years ahead of British and American designs. Even submarines carried periscopes with crystal-clear visibility unmatched by enemy vessels. It was a pattern, an entire technological doctrine, and the Panther sight was simply the most dramatic example of it. Another surprising discovery came when British analysts examined captured training manuals. German tank crews were taught to rely on optics as their greatest strength, trained for precision shooting rather than rapid firing. Instead of firing off multiple shells to walk their shots onto the target, Panther gunners were expected to hit accurately on the first or second round. Their technology made this approach possible, and their doctrine made it standard practice. British crews, by contrast, often fired quickly, letting the first shot reveal the enemy's position, or adjusting based on the dust kicked up by a near miss. This difference in philosophy explained countless battlefield encounters where it felt like the Germans were reading the terrain like a book while the Allies fought through trial and error. All of these revelations built up a single, haunting question among British officers. If the Germans had invested so much precision into their optics, what else had they perfected that the Allies had overlooked? And as they prepared to test the Panther optics further, against distance, weather, and movement, they realized the final, most shocking truth was still waiting to be uncovered. The final and most revealing test of the Panther's optics took place on a fog-laden morning at a British proving ground. Engineers wanted to push the system beyond normal limits, to recreate the same conditions Allied crews had endured in Normandy, the Ardennes, and the Hürtgen Forest. Heavy fog machines rolled across the field, masking wooden silhouettes shaped like Sherman, Cromwell, and Churchill tanks. From the firing platform, even experienced spotters could barely make out their outlines. One officer raised a standard British tank sight to his eye. He strained, adjusting the focus ring again and again. The fog swallowed everything. At 50 yards, the targets dissolved into gray smudges. Another officer tried binoculars, the best Allied-made models available at the time. The result was hardly better. The fog turned the world to chalk. Then the technicians mounted the Panther's sight onto the rig. The moment the lens aligned with the distant shapes, a murmur rippled through the observers. The silhouettes sharpened, edges appeared. Distances suddenly made sense. What had been shapeless fog now looked like a battlefield. The Panther optics cut to the haze with a clarity bordering on the unnatural, transforming confusion into definition. A senior British commander, a veteran who had survived battles from North Africa to Normandy, stared to the sight for nearly 10 seconds before lowering it in disbelief. "Now I understand," he said quietly. "Now I finally understand why they always saw us first." That moment became the climax of the entire investigation. It wasn't just about the lens itself. It was about what it represented. The Allies had been fighting an enemy who could see them before they were seen, aim before they could aim, and strike before they even knew they were in danger. Tank crews had always suspected this. But now the proof was undeniable. In their reports, British analysts went far beyond technical descriptions. They wrote of an enemy whose technological philosophy was fundamentally different. Where the Allies built machines to be simple, fast, and replaceable, the Germans built machines to be precise, specialized, and deadly at long range. The Panther was not a perfect tank. Far from it. Its mechanical reliability was poor, its production was slow, and its logistics were a nightmare. But none of those weaknesses erased the fact that, in the hands of a skilled crew, its optics turned it into a long-range predator. British intelligence summarized the discovery with unsettling clarity. In daylight or low light, in fog or smoke, a Panther gunner possesses a sighting advantage not matched by any Allied armored unit. But the true surprise came days later, when engineers examined an additional crate from the same captured vehicle. Inside was the Panther's auxiliary sight, the simpler, non-magnified backup optic. Even this primitive model was made with precision that matched or exceeded the primary sights on many Allied tanks. It was rugged, polished, and crisp, The British team realized the Germans hadn't simply made one exceptional lens, they had elevated optics across the entire machine. This discovery forced the British High Command to reconsider their own doctrine. If a future war ever broke out, tanks would need not just better guns or better armor, but better eyes. And so, quietly, without any fanfare, the seeds of post-war tank design were planted. The realization that optics could decide battles influenced every major armored vehicle developed after 1945. British Centurions, American Pattons, Soviet T-54s, all carried sighting systems that owed something, directly or indirectly, to the shock the Panther had delivered. There was a deeper, more human reaction as well. Among tank crews who heard the findings, the discovery stirred a mixture of awe and anger. Many finally understood why they had lost friends, why certain battles had felt unwinnable, why German tanks seemed to hunt them with ghostly accuracy. Yet there was also respect for craftsmanship of an enemy who, despite being driven by horrific ideology, produced machines of astounding technical brilliance. In the months after the war, British and American engineers toured devastated German cities, visiting ruined factories where Zeiss, Leitz, and other companies had once operated at full strength. Among shattered walls and fragments of machinery, they found blueprints, prototypes, and half-finished lenses that hinted at optical technologies far beyond what had been fielded. Some designs included early stabilization systems. Others showed advanced range-finding concepts. Had the war lasted longer, these innovations might have changed the battlefield even more dramatically. But the war ended when it did, and the Panther, with all its flaws and genius, became a relic. Many were scrapped, a few in the museums. But the optical systems that once gave its terrifying edge were carefully archived, studied, and quietly integrated into the next generation of armored warfare. Years later, a British engineer who had been part of the original testing wrote in his memoir, "In that moment when I looked to the Panther sight, I felt I was peering not at an enemy, but at the future." The Panther had shown the Allies a truth they had never fully considered, that the first step to winning a tank duel wasn't firing the gun. It was seeing the battlefield, seeing farther, seeing clearer, seeing sooner. And in that race, for a brief, deadly period in history, the German Panther had been unmatched. As the world moved on from the ruins of war, the lessons learned from a single captured tank would echo across decades. In the silence of a proving ground, through fog and fading light, the British command discovered something extraordinary. That victory doesn't always belong to strongest, but often to the one who sees first.